So hello and welcome to the Overland Journal Podcast. I am your host, Scott Brady, and I am cruising south from Cape York here in Australia with a good friend of mine, Stu, and we're going to chat about suspension. But before we get into that, let's give the audience a little bit of a background on your career, how you learned to be a suspension engineer, the kind of projects that you worked on, maybe that you're most proud of.
A special thanks to Hankook Dynapro Tires for supporting this week's podcast. Visit expeditionportal.com to see our content series in partnership with Hankook, where you'll learn about this year's Jeep Beach event in Daytona, Florida, get tips on exploring the Ocala National Forest, and take a tour of the Motorsports Hall of Fame of America at the Daytona International Speedway. We also take a close look at how to choose a mud terrain, all-terrain, or hybrid rugged terrain tire using the Hankook Dynapro tire lineup as examples.
Yeah, so I started at ARB straight out of uni 25 years ago after doing mechanical engineering and commerce, and I've had some great opportunities over that 25 years, and I've done some manufacturing, some fabrication, a lot of CAD work early days, and then started in Old Man Emu suspension in, I think it was end of 2005, late 2005. I was one of two in the team at the time. One of the guys left. I got an opportunity. I wasn't a suspension guru. I was an enthusiast.
I think that goes a long way.
Yeah.
I think it helps to be passionate.
So I was passionate. I was eager. One of the guys in that team of two ended up leaving, and I was chatting to the engineering manager at the time and just making small talk. You're replacing, the guy that left, and he said, "Yeah, but if you want to have a chat, let's have a chat." And so I had a chat, and here I am 20 years later. So
that's incredible.
I started late November. The one guy that was left in the team told me on my first day in Old Man Emu that at Christmas he was leaving to go to Perth and live with his girlfriend. So I was all by myself. So I'm pretty much self-taught. I've had some great mentors along the way that have been external to ARB as well, but basically self-taught through valving, working with suppliers, great suppliers in OE damper suppliers, coil spring, leaf spring suppliers. So educated but self-taught,
And I think that's how a lot of us are.
And picked it up along the way. So, and I've had some really awesome opportunities. I mean, even just when I started, there was one nitrocharger product. We had some coil springs, leaf springs, the basic fundamentals, and then really probably around the 2010, we got some new technology from Munro, who was our damper supplier at the time. Some new internals, so we basically rebuilt, revalved the whole range. So that was a fortunate timing for me, in terms of the range up until that point existed when I started, and then basically I went through, after hiring another two engineers to help me, we basically went through the whole back catalogue, got all the vehicles in, starting with the most, in 2010-ish, that sort of time frame. We basically started with the most recent vehicles, the most popular ones, and revalved them all again and worked backwards through the catalogue, probably 200 part numbers.
And I think what's really neat, Stu, is that, and why it's so applicable to this conversation today, but you're a passionate overland traveler yourself. You've driven all over Australia. You and I just drove up through the Telegraph track all the way up to Cape York. We're going to do, well over 1,000 kilometers together on this journey, and we've worked together on other projects. But because you've had access to this very full range of products, everything from internal bypass to monotube, dual tube dampers, coil springs, parabolics, leaf springs. You've really had access even to bushings, progressive jounces. So we're going to go through all of those concepts because the goal here is to help the listener understand the principles of suspension for overland travel. And I think it might be good for us to kind of riff a little bit on what is the job of a suspension on a vehicle like this 79. What would you say are the 2 or 3 primary roles that a suspension is playing right now with us driving down this track?
Yeah, so this is a pretty heavily corrugated road. So really what the suspension, if we break it into springs and dampers being probably the most fundamental parts without digging into the bushings and everything, the spring is holding the mass up of the truck, and the damper is basically controlling the motion of that mass on the spring. So they have 2 different functions, those 2 things. It's not like you get lift out of a shock absorber or a damper,
Sure.
So the springs, they support the mass, and then the damper controls the mass on the spring. So
yeah, and we have a lot of weight in motion, and a lot of times people think a spring's job is to kind of set the ride height and get the vehicle level with the load, or to be able to manage a certain amount of load. And that's certainly one of the things that it's supposed to do, but it's also trying to manage mass in motion.
Yeah.
So not only is the vehicle experiencing turning forces, compression forces because of the changes in the surface, but also you have these heavy, on this vehicle, you have front and rear solid axles that are reciprocating mass.
Yeah.
So those things, going over this corrugation, those axles are cycling hundreds of times a minute, if not thousands of times a minute.
yeah, so you have your sprung and your unsprung, the bits that sit above the spring.
Yep.
And
So
then
let's
your-
explain a little bit
Yeah.
to the listener the difference between sprung weight and unsprung weight, and then how we help tune the suspension to address both of those.
Yeah, so the sprung mass is the mass that's sitting basically on top of the spring, being supported by the spring, and the unsprung mass is the part that's basically, in this case, under the spring and not being supported. That's seeing the excitation from the road, and that includes things, everything that's under the spring, from the axles, wheel and tire assembly.
Yeah, the brakes.
So, the brakes, everything that's hanging, off the spring, under the spring, that wants to jump around as well. That's your unsprung mass.
And that's where, the weight of the wheel, the weight of the tire becomes such a critical component. And we're going to talk about that a little bit later, because a lot of times people's first inclination is, how big of a tire can I fit on the vehicle? And that may not always be the best approach. Now, diameter has a lot of advantages, but just a big heavy tire or a big heavy wheel and tire combination that looks very suitable for off-roading doesn't actually mean it's the best tire and wheel combination for overland travel. So I think now that we've kind of given those overviews, let's go through a couple like glossary of terms, and I'll ask you some terms and we can talk through that. So let's talk a little bit about spring rate.
Yeah, so spring rate is basically the stiffness of the spring. How and it's depending on what part of the world you're from. It might be newtons per millimeter or pounds per inch.
Sure.
So that's basically the definition of spring rate is how many inches of deflection or change from its free height do I get as I add mass to it. So if you have a 500 pound per inch spring, that people are probably familiar with that type of number.
Sure.
If you put 500 pounds on that coil, it's going to come down 1 inch. And for every inch after that, if it's a linear rate, not jumping ahead too much,
Sure.
but if that's a linear rate, for every additional 500 pounds you put on it, it will come down another inch.
That's right.
Yeah.
And that can be achieved in a couple different ways. So for example, coil springs will reflect in that way unless they're progressive rate coil. Sometimes they use the way that the coils are wrapped. It allows for a little bit softer kind of initial travel, and then it comes into a heavier rate as you compress the spring. And then of course leaf springs, which I think it's very easy for people in 2025 to kind of dismiss the leaf spring.
I love a leaf spring still.
A leaf spring has a lot still to offer
Yeah.
to the traveler. first of all, it does a way better job of managing a variable load than a coil spring does, in so many different ways, because you can progressively come into the pack as you add weight, and you can even have overloads, and it's very easy to make a durable, easy to reliable, easy to maintain spring. And also the leaf springs do the great job of locating the axle at the same time.
Control arms,
yeah, so you have a lot less components and all that other stuff. I remember the BJ74 that we built years ago. It was leaf sprung front and rear with that little 13 BT, just an awesome little 100-inch wheelbase Land Cruiser. And it was, leaves front and rear. And if you pulled the sway bar off on the front, it had way more articulation than a coil sprung 70 series has today.
Yeah, and I'm sure you said that the other day of the rear of the Hilux as well, about how well that was moving.
Really did well with those parabolics.
Washed out sections of track.
Yeah, so I think leaf springs it's easy to kind of dismiss them, but they're used in heavy duty truck applications for a reason, and that's because they can do a great job of managing a lot of weight. And here's the other thing that a lot of people don't realize, that the weight is now supported on two ends. So if you have a coil sprung rear suspension, it puts an enormous amount of frame loading when you have a heavily loaded bed.
The frame is designed to take the loads at those spring locations. Yeah.
That's right. So if you see a coil sprung truck with a bent frame, it's because they either got the load way too far aft, or it was way overloaded and it actually can bend the frame. Whereas a leaf spring will support the load at the very end of the frame member and further forward in front of the rear axle. So it does do a nice job of changing that point loading.
It really does distribute the load through the frame.
That's right.
Rather than being a point load. Yeah.
Yeah, so it's good to remind people that leaf springs do a great job. And since it's kind of the oldest form of spring that we have today, let's talk through what are some things that people should look for in a leaf spring that's going to help it be more reliable, more effective in your mind.
And I think even starting with rate as an example, and there's probably different ways people go about trying to modify a truck or modify a leaf spring, often for lift. But really the way we look at it is around rate and about what the payload of that truck is, how you're going to use that payload. We typically, when looking at an OE truck as a project for a leaf spring, is can we divide up that payload, and can we look at a special design for each segment. So we say maybe the first 300 kilos, 600 pounds is going to be this spring rate, this design of leaf. Then we might do a second one with a heavier rate and heavier again. Because if you just whack extra leaves in there to get height, you're not changing the free camber of the spring. You're just basically blocking it with steel that makes it stiffer and doesn't want to move, particularly if that's a light truck. You're not considering the load on it. So you could almost do anything with the damper and not get it right if you've just jammed all this steel in there that's not allowing the system to move.
And a lot of times those very flat leaves that even have quite a few packs, they can do pretty well on droop travel, where they're going to suffer on compression, which is where those parabolics and that free camber that you have in the leaf pack helps to provide good compression travel, controlled compression travel, and controlled extension travel. If the leaf pack is over the axle configuration, what are some ways that you see manufacturers adding lift to the
typically the way we do it is we start with a whole new leaf pack, and we start by looking at those factors exactly like you said. What's the distribution of travel? How much compression up travel is there? How much droop travel is there into full extension? And then what is the limit of that travel at that full extension condition? Is it brake lines? Is it other bits and pieces? And that's where the damper then starts to come in and play. But typically we start with a scientific approach of how much mass are we designing this thing for, what height do we want to hold that mass at, and then what sort of rate do we want to be able to support that mass correctly and not have an overstressed design. So that's where we go through this cascading approach of establishing that sort of architecture, I suppose, of what height do we want that mass to sit at, how does it move through that amount of travel we're allowing it to have within the shop movements, and how much bending is happening in each of those leaves, and how much stress is going into those leaves as they bend. Because you could make it, like you could make a spring stiffer by adding steel in, you can make it softer by taking it out. So you can make this big, long, flexy leaf that will have to have a lot of free camber when it's out of the truck. So that when you put your weight on it, it comes down, but it's going to lose a lot of height as it does that, because it's not got a lot of rate in it.
Yes, and then there's other
factors. And it's also because you've bent it so far, you're now putting a lot of stress through that design.
And you're going to need a really long shackle to be able to manage the spring lengthening as it's compressing.
Correct. So there are a lot of factors, and I know, it is an old technology, but I enjoy working with people, and I enjoy working with the suppliers, and we do a lot of stress analysis, computational stress analysis, FEA on the spring design, on the steel in the springs, and then typically we get into this point that we've got a primary stage that rides really nicely, supports the load, and then we bring in the helper or the second stage leaf, the overload leaf. And that helps support it as it gets further into the travel. And we find we get really good results and good spring rates by pushing that primary stage away from the helper.
That makes sense.
And then you have that initial travel that's not being ramped up and upset by that interaction with the helper. And you get that really nice plush initial ride, and then it rolls. The way that the primary then rolls and engages onto the second stage has a progressive approach that doesn't give you this, if you had the helper that was sitting flat and a leaf that came down and struck it when it was flat, you just get this stop. So we design the leaf so that it rolls nicely onto the helper, and that's normally the fine-tuning part of the leaf spring, and that's where I often negotiate with the suppliers and my engineers to understand the stress, because we want it to ride comfortably, but we want it to be durable and long-lasting, and that's where our OE level supply chain are really good there. The level of quality that we have is we maintain that. I always want to move the second stage away a little bit to get more plush zone. They say no, that's going to increase the stress too much, and we get this compromise, and we get to this. It's a joyful, process. I enjoy it. Working with the suppliers, and we always have this banter of how much stress is allowable and what the particular application is. We really, it's not a rinse and repeat. We do consider the payload of the truck, how the truck's going to be used.
And let's talk through some of the other technologies or the other considerations for leaf springs. What are your opinions on the second leaf down having an eyelet wrap? So you have a secondary wrap around the eyelet on the end, just in case you have a main leaf failure. You guys have incorporated that in some of your products in the past. Is that something that you still do? If not, why have they gotten away from it? What are your opinions on that?
We would call it a military wrap. I don't know if that's how it's called through the industry, and it's a fail-safe for eye breakages or overloading of the eye and trapping it all there, so that the vehicle is still serviceable in that
at least get you
event.
Home.
At least get you home. And I suppose the things that have changed a little bit over the journey is that a lot of the OEs don't necessarily package for that feature, and when we're going to...
So it won't fit.
Basically. So when we go to make an aftermarket solution, we can't always get a military wrap in there. If we can, it's a good feature to have, but lots of the more recent applications don't always have the room for a military wrap.
That's good for the audience to think about. If you're looking at leaf springs and there is a packaging space for a military wrapped leaf spring, you may want to consider that. And of course, the most important place to have it military wrapped is on the forward end of the spring. But that's usually where the packaging problem is, because you can go with a longer
The
shackle.
hanger,
You can go with a
So
longer
we would
shackle
call
in
it
the back.
the fixed end,
That's
the front end of the spring. But I suppose it comes into that design and over engineering. I think that we're very good at that in terms of we understand where the limit is, and that's why I enjoy working in the aftermarket, is that we understand where that limit is through our calculations, through our experience, what the stress is, and then if we need to put another 10% on it, to give that extra level of confidence or durability, if the military wrap is not available, then we've done the calculation, we've done the testing to understand that it's going to be okay.
And that's part of the advantages of the modern day, is that finite element analysis and all of that stuff is so much more advanced than it would have been 80 years ago when the military wrap leaf spring was of a real consideration. So I think that if you have the ability to package for it, it's definitely worth considering. Let's move on to some of the other technologies that you see in leaf springs. What are your thoughts on interleaf friction pads? What are your thoughts?
That's an interesting one, and there's been lots of different theories over the journey. Of different.
When you first get them, they're great.
Yes. Yeah. And we do have interleaf friction pads.
Yeah, sure.
We've experimented with different materials.
Sure.
Different lubrication, running dry, running lubricated.
And what are your thoughts
on what environments that they're in? Well, in theory, the pads themselves don't need to be lubricated if they're of the right material.
Gotcha.
But it depends how you use it and how you maintain it. And leaf springs, not modern cars. People don't expect to have to maintain modern cars, but leaf springs, like we're driving on dusty roads, through silted, creek crossings. All of this sort of stuff, a lot of water. So leaf springs do require maintenance, and I think that's part of the understanding of the use, the use that people are putting them through. If you're running them all day, every day on the road, they're fine. And if you wanted them to be, silent, a little bit of lubrication doesn't hurt. Also, adding those interleaf liners in between also provides opportunity for contaminants to come in there that start making the noise or start doing the scratching as well. I remember in mines, this would probably be 20 years ago, talking about in certain mines here where they wouldn't run any interleaf liners. They had big multi-leaf packs, no liners, leaves up against leaves, to keep all of that mud and grit and dirt out that you get on, mining roads.
Sure.
And that's what they found worked for them, and
everything is so application or condition.
It really is, and
really
there's that sort of experience, build up of experience, and customer profiles. That's why we enjoy working with our customers. We're out doing, some more marketing trips, but we also do lots of engineering trips, and we work with our specific customers, our fleet customers, like the mining experience, the forestry departments, all these people that use our aftermarket products for their daily jobs. We're embedded within those industries to get this feedback.
I do find that, like, if I have interleaf friction pads, just every oil change, when you get underneath and you grease your prop shafts and you do your regular service and inspection, those typically are really easy to do. Take a little bit of weight off the vehicle, and put a jack stand under it, take a little weight off the vehicle, and then they just have these little pinholes, and you just squeeze some grease up in there, not too much, just a little bit, just a little bit. People tend to overdo that, and it quiets down the packs. It does improve kind of that initial engagement, the smoothness of the springs, or at least there's the perception of that. Now let's talk through another feature that there's wide opinions on. It is the clamps that go from the leaf below it, clamps around the leaf above it, or maybe even multiple leaves. What have you found in your experience and your testing is kind of the best way to go about the clamping of leaf springs?
So
we've got a nice little water crossing coming up here. Oh no, it's not that deep. It looked more exciting than it was.
A big hole in front of it.
Yeah, as everybody's listening to this podcast, we're literally driving through the Australian outback, just did a little water crossing here. So if you hear me go quiet for a second, it's because earlier I almost whacked a pig at about 80 kilometers an hour. So glad that didn't happen. He
wasn't
kicked
a
it.
little guy.
No, it was big. And did you see it? No, when it got off.
He was in the bush before.
Yeah, jeez. Yeah, I mean he had to have been, 60, 70 kilos. He was big.
Yeah. So clips, we've always had a clip that is riveted to the bottom leaf. So there's a countersunk hole in the bottom-most leaf. Typically, the overload leaf, and it's in an area that's not highly stressed. And then, because the way we work with our customers as well, and the way people build vehicles, we have a bolted clip, I suppose you'd say. So it comes out, a U-clip goes up and covers maybe the whole pack or most of the pack.
Sure.
You might have one or two clips either ends of the leaf, and that's an application-specific one too.
And help the listener know what is the job of the clip, and then I've got some questions after.
So the clip is to keep the leaf pack aligned and
so it doesn't splay out.
So it doesn't splay, and it keeps then that distribution of load through the spring in the right places, so that you're getting that durability, that long life. So it's all that we're all looking for that. That's what we're doing. We're trying to provide a dependable, robust solution. And the reason we have a bolt is because sometimes our customers, as they build their truck, we can add an extra leaf into that pack.
Sure.
So and then even again, like you're saying with the interleaf liners, we have a little liner on that clip as well, so that doesn't generate noise as the leaf splays and makes contact with that clip.
Well, and there's a couple different ways of going about the clips. Sometimes the clips are very tightly wrapped around the spring, which people will oftentimes see that as a negative, like, oh, that's going to take away from my droop travel. But like you said, when you're going application specific, certainly having open clips or clips that have a very tall side on them, so it allows for a lot of droop out of the springs, that can be an advantage for extension travel. But especially if they are not clipped, that's when you tend to see springs bent. And it can also increase the amount of axle wrap that you get out of the spring pack. So I do like the fact that you guys allow for a little bit of additional droop travel with a slightly taller, shoulder of that U-bolt. But then it's not so tall that you can end up with bent leaves, or you can end up with too much extension travel.
Yeah. And it is application specific in terms of the placement, the amount those leaves will splay as well, because basically the pack is bolted to the axle, and it'll want to move where the axle moves.
Sure.
But the leaf itself, like you said earlier as well, is anchored at the fixed end and at the shackle end. So that sort of has to move, and particularly in articulation events, because it swings on the shackle, as you flatten that leaf out, that side of the axle will travel backwards.
Yes.
And then if the other side is going into droop or extension, that's going in the opposite direction. So even though, you're driving straight down the road, and as the axle articulates, the wheel is actually moving front to back and twisting. So it's that twisting motion of the springs attached to the axle that want to make them splay.
And I think a lot of times people focus too much on droop travel, but one of the things that the clips do actually is help provide a return to center. So it's the same reason why you might anchor the top and the bottom of a coil spring. So that way when the axle drops away, there's actually a return spring component that's pulling the axle back up into position. And it's the same with leaf springs. It helps kind of control some of that rebound because there's this return to center or return to the static position forces that are going on because of those clips. All right, so we've talked through some of the leaf spring stuff, which is kind of, I mean, that's back to horse and buggy days.
Yeah, it is.
Leaf
Yeah,
springs.
it is.
Leaf springs have been.
There's
around
been a
for
little
very
bit of
long time.
technology though. It's crazy that what people will do, and I think you mentioned parabolics.
Yes.
Which is I suppose.
Let's go through parabolics.
yeah.
That's great.
That's a leaf technology. So while it is, horse and cart, there has been refinement in the concept. So typically your leaf spring is a consistent thickness of leaf. So we obviously talk in millimeters. Common for us would be 6, 7, 8 millimeter leaf. That is a flat bar of steel, typically 60, 70 millimeters wide, maybe 3-inch wide, that sort of size. And it's heated, and the eyes are rolled, and then it's plates or leaves individual that are stacked up to make the leaf pack.
Sure.
So that's typically how it's been done since horse and cart. And from a stress point of view, a ride point of view, normally more thin leaves are better than one or a couple of thick ones.
Sure.
And the difference that's evolved into recent times and become quite popular in the market is the parabolic leaf. And what that is a leaf that is actually thicker in the center around the axle, and then each individual leaf tapers out thinner towards the eyes, so that you can get some progression. You have the steel where you need the steel for the stress point of view, so that you're not having failure, but you're getting the best ride quality, fatigue life results out of this parabolic leaf. And
Maybe like a progressive coil in a way.
Yeah. And because we're sort of optimized that stress distribution, we've been able to take out the material where we don't actually need the material. It's just there because it's a connector between the middle and the eye. We can actually thin that material out, and we get benefits in ride, but we also get massive benefits in weight as well.
Sure.
You know?
Lighter, and that is a factor.
Yeah.
When you look at leaf springs can be significantly more weight than all of the 5-link components and the coils and the dampers combined for example, in a 5-link application. So leaf springs can be very, very heavy.
And I think just on this 70 series, it was one of our biggest leaf packs was sort of the high 60s, up to 70 kilos per side.
That's insane.
And we were able to design a parabolic equivalent that was 25 kilos a side.
Wow.
So
Is that what's on here now?
That's what's on here now.
Wow.
So we've saved.
And it does ride nice.
So yeah, it rides really well. But that weight basically is weight now that you can use in your payload.
Yes.
When you sit the thing on corner scales and you've got the weight on the tire, that's 40 kilos a side, perhaps, that you can now have on top of the truck.
Fuel.
Yeah.
Yep. So then there are some additional considerations around leaf packs. Sometimes you'll see vehicles equipped with a monoleaf. Sometimes that monoleaf will be made from metal. Sometimes that monoleaf will be made from fiberglass even, or other composites. In general, they just haven't worked out well. There was a monoleaf spring application for the Ranger that I experienced a lot of step out, very poor control, lateral control out of the vehicle because the spring just wasn't responsive enough. So, but there are monoleaf applications that can be really effective.
Definitely for passenger vehicles. I think that's the thing. We tend to put our components into harm's way. In these conditions. So, you can get contact with rocks and other things off road. That can create stress rises, in the components. So it is, particularly when you're remote as well, you need that reliability. So
there's a reason why the 70 series still has a multi-leaf pack in the rear.
Yeah,
absolutely. All right, so I think we've got the leaf springs themselves discussed. Let's move on to the shackle a little bit, because I remember when I was first getting involved with that, one of the cheapest ways for me to lift my Isuzu Amigo was to put taller shackles on the back.
Shackles,
in the back. So help people understand, what does that do that's good, and what does that do that's bad?
I suppose in Australia, that's not a thing for us. we have really good good and bad, I suppose. But we're regulated that we can't increase shackle length.
Okay.
So that's
not at all.
No, not at all.
Interesting.
Yeah.
So then help the listener understand why that might be from an engineering perspective. Yeah. Why do you want to be mindful of the length of the shackle? I mean, I have some thoughts, but I'd love to hear yours.
But if you get that wrong too, it creates a difference in lateral movement too, and the way that the spring moves through its arc, and the way that it moves up.
You can get a negative arch.
Yes.
A really dangerous negative arch that can cause spring failures.
Which is exactly what we were talking about before. If you're over compressing, overextending, putting more travel into that leaf that it was never designed to take.
That's right.
Then you're putting it in this overstressed potential fatigue condition.
Yes, that's right.
So if you're not adjusting bump stops, and sometimes it's one of those snowball things. You adjust one thing without the full picture, but it can snowball into the requirement of modifying heaps and heaps of other things then down the track.
And of course, our goal in this conversation, we're focused on vehicle-based travel. We're focused on, we did some very technical driving the last couple days, but it was stuff that could be done with essentially a daily driver vehicle with some minor modifications, and of course a snorkel with how deep the water was. Yeah. But in the US, there are certainly applications like extreme rock crawling where people may push the limits of that, but then you're really compromising your limit handling capabilities of the vehicle, especially if that longer shackle doesn't have some kind of a center welded element or at least a bolted element to keep those uprights from flexing under lateral loads.
Yeah, the side plates. And I suppose that's the thing. And again, we talk applications and the way people use vehicles. And often that rock crawling stuff will be trucked to the location where we haven't, trucked anything here.
No.
We've driven for days, lived out of vehicles.
That's right.
So it is, and I love understanding those segments of how people use vehicles.
And there's a lot that can be learned from racing and from rock crawling. Yeah. And plus, rock crawling is a lot of fun.
It's not a negative.
Yeah, it's just not what we're doing as travelers.
But I think we've found too, though, out of these vehicles, like you said, that are potentially our daily drivers. They literally are daily drivers, but the events and the obstacles that we've encountered, a 2-ish inch lift, with some good tyres and appropriate tyre pressures, we've been able to really have some good challenges. We could have had more lift and bigger tyres and just, blasted through a lot of this stuff. But I think the builds have been appropriate and reliable,
And that's actually one of the things that I mentioned this the other day, but it's actually one of the things that I really appreciate about Australian overlanding in general is because of the regulations, everybody's vehicles are pretty similar. Slight variations. You're not going to see a truck on 40s on that track, or you're very unlikely to see a truck on 40s on that track because it is a named road in Australia. It's subject to all of the regulations. So because of that, all of the vehicles are within a very small range of capability. Imagine if somebody went through that track on 40s and they were digging ruts 40-inch tires deep. Everybody that came after them would struggle and wouldn't be able to get through. They'd be winching.
You'd just be winching.
Whereas because all the vehicles are so similar, it's so much more gentle on the track, and it's easier on the people that come behind you.
And it's still a challenge, though.
Very much so.
It's not to say that it's, you can stick 40s on and blast it, no worries, but
we had to work for it.
The level of challenge is still there. Yeah.
We had to work for it. When I crossed Nolan's and that water came up, cresting up my windshield, that was pretty impressive. Yeah. That was pretty impressive. All right, so let's move on to a different kind of spring, which is going to be a coil spring, and then we'll get into some air springs after that. Yeah. So coil springs have become the most common application for most overland vehicles now. In the US, we're seeing that more and more in the rear of SUVs and even trucks now. Yeah. And they're used as a coil over in many front independent suspension systems. It's very rare anymore to see a torsion bar spring, so I guess maybe I'll just touch on that very quickly. Early Isuzus and some Mitsubishis and even
I think Toyota had it for a generation.
they did have a couple generations with torsion bars. The 100 series independent front had a torsion bar on it. The only one that I'm aware of that currently still uses it is the heavy duty GM applications use a torsion bar in the front. And that's basically a long spring that twists to provide rate and then you use a keyway and a bolt to put tension on the rod that's being twisted to change the ride height.
Yep.
So
it seemed to come and go within a generation. You know, we went from leaf spring fronts to torsion bars that were there, I think, for one generation across multiple manufacturers, and then we're into coilovers pretty much.
The really big downside is they were prone to failure and they very limited total range of travel. So it's just by the nature of having a twisting rod, a twisting spring, you can only get so much travel and packaging out of that. So you just don't see people really using them anymore. So now let's move on to coil. Describe what coils are, how are they manufactured, what to look for in a coil spring.
So coil springs are basically a long bar. Starts out straight, and then it's wound around a mandrel, typically, to make that long straight bar into a coil spring. It can either be hot wound, cold wound, and there's lots of slightly different techniques, and there's lots of slightly different tweaks you can do from a design point of view to achieve.
Process or anything else.
And even I think you said a linear spring, if we start with that, is one that is of consistent section, so it's the same diameter of bar all the way along the length of the coil spring, and then that's wound around a mandrel at a consistent pitch between each coil, and that gives you that linear rate. So if, say, we said earlier, 500 pounds on the coil brings it down an inch. You put another 500 pounds for a total of 1,000 on the spring, then it comes down 2 inches. So a total of 2 inches, but it's still the same 500 pounds per inch rate. And then we can sort of get a little bit more advanced from that, and with a consistent bar diameter, we can do what we call progressive pitching. So if we wind the coils a little bit closer together, that can give you a bit more of a progressive rate. So where they're wound a little bit closer together, they're more likely then to compress before the ones that are further pitched apart.
That's right.
So that's within
and that's just because of leverage.
Yep. And that's within the control of that rolling on the mandrel process. And then the next one, I suppose, more advanced again, is that, and this is one that we do with our springs, is as that bar comes out straight, you can peel the bar down, so you can have a progressive wire diameter as well.
Sure.
So it's not just a consistent wire. You can, as you can feed that wire through a machine to basically peel it like a carrot as it feeds through.
Sure.
You peel it down on a lathe, and you can have a bar that is sort of maybe 20 millimeters at one end, down to 10 millimeters at the other.
Sure.
So then the skinnier wire, the smaller diameter wire, is easier to compress, and so that's how you can get a compressive a progressive coil as well.
And it just, for the listener, it really helps with that initial, call it 50 millimeters or so of travel, compression travel. It's just going to make the ride feel a little bit more subtle, a little more supple, a little bit more comfortable. But then as you come into the heavier rate through the compression stroke, then now the spring is actually helping to slow down the load in conjunction with the damper.
Yeah, and it is a good one for the Overlander, considering particularly where we load unload in the rear of a truck. You definitely get the benefits of having that supple ride height feel, but then also as you add load. So if we said, hey, a softer spring is the best riding spring, just as an example.
Sure.
The downside to that in our overlanding condition is that we might have it riding beautifully at ride height and it's perfect when it's unloaded. But as soon as you start to put load in, it's going to start coming down at that 500, at that 1 inch per 500 pounds.
Sure.
So it's going to keep coming down like that. And you'll load up for your trip. If it's too soft a rate, nice riding. But as soon as you put the weight in to go away or your gear in, it'll come down and you've lost all of your departure angle, you've lost your ride height. So
I mean, it can affect things like, for example, you'll see trucks like in Southern California going down the road with the rear end squatted like a Baja race truck or whatever. That significantly changes your caster.
Yeah.
So I mean, and that has huge implications on the handling of the vehicle. So the vehicle is designed to have a certain amount of caster. If it's too stink bug in the rear, you end up with when you put a steering input in, it will be more direct, which means it'll turn in more quickly. And the more that front end is high, the more slow the vehicle will be to respond. And depending on how bad that is, you could even end up with some death wobble.
yeah, and so the way I've come to understand that is the roll axis as well. So if we have that roll axis between front and rear, and how that's set up, but
it's designed to be. I mean, think about the Toyota engineers. I mean, I've been to Japan and I've talked to these guys, and they care so much about being precise about how those things work.
Yeah.
So don't think that some mom and pop suspension company in Southern California or whatever has got it all figured out. Like, really question any significant departures from factory specifications, whether that be alignment or the angle of the amount of lift in the rear, the amount of sag out of the springs. All of those things are a big factor. So
it's almost fast fashion.
It is.
Some of that
It is.
stuff.
It is.
Some of
It
that
is.
stuff.
It is. It is.
It's
Just to be a
going for
little
the look.
different. Just to be a little
People
different.
that are going for the look rather than the function. And I think that's the thing with the coil. So we were saying that a coil that can be soft can be nice, but not great for loading. So not good for functionality.
And it can feel downright dangerous once you put a load in there.
Yeah, and then when you do hit a bump, so that's just in a static condition. But when you do hit a bump, you're closer to the bump stop now. You've started statically closer to the bump stop, and you haven't got that spring, providing any resistance to hitting the bump stop. And particularly as an overland traveller, you've got that weight on. When you hit that bump stop, you're transferring all this load now through the frame and the components and all of that.
And the passengers.
Yeah. So, and then I suppose the alternate to that soft spring approach is the firm spring approach. But the firm spring approach has its downsides too. That at ride height, it's too stiff and jarring, and it's not supple. Yeah, and it affects traction. So that's where the progressive coil definitely has its place to provide that supple, on center feel, ride height feel, rolling plushness. But then you come into some firmer rate to hold that weight up as you load it up.
And it's all a balance, because
It is.
if the spring is too light on its capacity and your load is too heavy, you can get the spring compressed enough that you end up with spring slap. And spring slap, after a very short period of time, can result in a broken spring. When that spring is smacking into each other, it can actually crack and break the spring. So we never want to have spring slap, and you'll hear it. And then we never want to use spring length to address a rate problem. So if you're trying to carry more load, going with the same spring rate but just longer isn't solving the problem. It may look like it's okay, but now you're getting into that situation where you're going to end up with spring slap and you're not going to properly control the load. And then we also never want to use rate to gain height.
No.
Because now you're going to end up with a terrible riding vehicle.
Yeah.
Your traction will be affected.
Yeah.
It's not going to articulate properly. So it really is that sweet spot.
Yeah, it is. It is. It's understanding the application, the customer, how they use it, how they load it.
Yeah.
And I suppose from a design point of view, I know we've spoken about that. that's some of the stuff we do up front.
Yeah.
You know.
Take the time to do that.
Yeah.
All right, so now let's dig in a little bit to, which is common in a lot of application, let's dig into air springs. Why would people use, or why would OEMs fit air springs, or why do people put in either a replacement for a coil spring as an air spring, or do they use a supplemental air spring or a helper spring?
Yeah. So in Australia, we have our regulations again that sometimes helpful, sometimes not so much. So for us to change a suspension system is a lot of work and a lot of regulation. So a leaf spring vehicle, to take that and change it to a coil spring, it gets done, but it's a lot of work. To change it from a coil to an airbag on its own, that's a lot of work. So a lot of what we see is a supplementary airbag that is a helper.
I think it's in this one.
It's in this one. So this is parabolic with airbag. So,
and it makes a difference. I mean, I think I'm at 15 PSI right now in the rear bags, which just kind of help a little bit with the sway, but we're getting that nice full travel.
Yeah, we're using the travel, and like we are here, that's our most challenging customer probably, the load unload guy. You know, if everybody was static in their load and their vehicle set up every day, you can go back to the science of like you said, you know, the Toyota sort of approach of getting it right and getting it precise and doing everything there, but that's not the breadth of our customer demographic, you know.
Yeah, they have a lot of needs.
There's lots of different, no two vehicles are the same. Yeah. They'll have different accessories, they have different needs, they have different loads. So that's where I think the airbag has its place. Often we see it be a bit of a band-aid at the end. You know, the last thing before a trip or a journey is people underestimate what they're doing. They overload and then they go, oh, I'm in this bad spot. My car's too low. I'll just put some airbags in it. And unfortunately what we see there then is that the original spring is not designed to be doing that work, and they're putting this bag in to be the band-aid. And rather than taking all of that load through the hangers of the leaf springs, say in this condition, they put an airbag in the middle into an area of the frame that's designed to take some occasional bump loads, but not the constant load of a really stiff airbag that's got lots of pressure in it, making up for the fact that the original leaf spring wasn't built to do the job.
I think that's the most important point, Stu, and I'm glad you brought that up. If you know that your load is going to be fairly constant, there's not an argument in my mind for an airbag. If, like, this 79 is a great example, it's unlikely that someone that built a car like this is going to be, you know, taking the canopy on and off and everything else. It's very unlikely. It's probably going to sit just like this. And in that case, you know, airbags is maybe like, oh, it'd be kind of nice to do a little load leveling, or maybe I'm extra full on fuel, possibly. But I think you take the time to get the spring rate right for this consistent load. Yeah. But if it is someone who's like daily driving their vehicle and they're taking the kids to soccer practice, but then they're putting a 3.5 ton trailer behind it, airbags might be the best choice.
Yeah, because that's an occasional user in my mind. You know, like exactly like you said here, and that's been our approach to parabolics. Actually, is that we wanted to come up with this leaf spring system that was the best riding, best loading system. So we've designed the parabolic pack. So it's a 3-leaf pack in this case. Sure. That replaces I think an 11 or 12 leaf multi-leaf design. But we have no helper because we're really looking for that premium ride quality. So we've segmented the payload of this truck, and I think we've got 3, maybe 4 different parabolic options that are designed to take load. So we might say if you're typically 0 to say 300 kilos, have this spring. If you're 300 to 600, pick this spring. If you're 600 to 900, pick this. And then if you're a fleet customer or a heavy build, always heavy, you might be 1,000 kilos, pick this parabolic leaf spring. And then what we do is we use the airbag in the middle to go between those. So if we say, hey, we've got a 300 kilo build on this, with a fairly light tray and some accessories on the back. And then on top of that 300 kilos, we might put some gear in it occasionally to go away. When we do that, then we pump the bag up like we have in this case. We've got gear on board, we've got food and all our stuff. So we've pumped up 15 PSI into the bags. But if we took all that overlanding type gear out, but we've still got a fridge in there,
Sure.
We've got some drawers, they might be empty, the MITS alloy tray. So we've got a constant build, and we pick the leaf for our constant build of accessories, and we just use that.
Tune it a little bit.
Tune it a little bit with the airbag, and like the towing the boat, towing the camper occasionally. That's that fluctuation that we look after. With
And there are some vehicles that come from the factory with air suspension on all four corners. The most common of those is going to be the Land Rovers.
Yep.
That gives them a wide range and ride height, so they can go into very high off-road modes and maintain reasonable quality ride. The downside to that, though, is that you're just adding rate to get height. So the ride starts to get very busy. It starts to be not as plush. There's a lot of pressure in the bag. So understand that everything's a compromise. So with those airbags, once you start to try to dial in a lot of lift height using a variable height airbag suspension system, you're going to start to reduce your ride quality as it gets taller. Now there is another application that I've seen from the OEMs, and Toyota uses this primarily in their Lexus products, and that is they have a hydraulic spring plate. I mean, it's brilliant. So all it does is change the position of the upper coil bucket. So it forces it down to change the right height upper spring plates. And I think that's just brilliant, because then the rate of the coil doesn't change, just the height of the coil position changes.
Yeah, because the weight doesn't change, does it?
Right.
So the spring doesn't compress or anything, that stays where it is. And you're just basically lifting the car.
It's very clever.
With those hydraulics.
And you get a really supple ride even at the off-road ride heights. It does change it a little bit because your A-arms are at a little bit more of an angle. There's some more leverage and you feel it a little bit. But it's pretty good. And it's also the way that they manage load leveling for towing a trailer and everything else like that. So in my mind, if you want variable height, that's probably the best system I've seen so far is that Lexus system.
Yeah.
All right, I think we've kind of talked through the majority of the springs. We've talked a little bit about airbags. Oh, let's talk about one more thing on the airbags. What are some things that you have found to improve reliability, or are there products that you found that you really like? I know that ARB makes some, but there's also, like in Australia, there's Airbag Man, there's Firestone bags. Are there some that you've found, like these are really reliable, that you've found to be more reliable?
Yeah.
And a special thanks to Warner, home of the Ineos Grenadier and the Mercedes-Benz Van Center. Warner. Whether you're traveling through canyon country in your Sprinter or across continents in your Grenadier, Warner has become a trusted stop for serious overlanders. I have personally serviced my quartermaster at Warner and have seen the work they do to their successful Rebel Rally competition Grenadiers. Matt Scott has experienced Warner too, helping his father-in-law buy a Grenadier from the dealership a few months ago. Warner has become known for supporting travelers in both Grenadiers and Sprinters, whether it's outfitting, maintenance, or helping with complex expedition builds. I have seen their team contribute to the community through sponsoring events, Rebel Rally teams, vehicle training, and remote technical support. It also helps that Tony Warner is an Overlander himself, so he is committed to fitting high-quality components and helping fellow travelers. As a thank you for the podcast listeners, they are offering $500 off a new or used Ineos or Sprinter, or 10% off parts and service up to $500. Just tell them you heard about it on the Overland Journal Podcast. Thanks again, Tony, and the Warner team for your support of this week's podcast.
I suppose most of those are really quite reliable when considered as part of a system and not just as a band-aid.
Yeah.
And we, in this case, we chose, because we did try benchmarking what was on the market and what our suppliers had on offer in their parts bin, and we chose to tool up our own bag. And that was as much around the travel requirements that we wanted. We didn't want to put a bag in there that was off the shelf and too short and wouldn't allow us to, you'd be ripping the bag in half under full extension. So that we didn't want to then go, we'll fill that gap with just packer plates, because then that was going to restrict our compression travel by having this short little bag in there. So we've taken away from the, because you also need bags, you need brackets to mount bags, so they take up space, so you can have a reduction in compression travel there. So that's where we've found with this combination of the parabolic that has a smaller stack height, particularly for the above axle. So you can maintain that compression travel. So that's some of the things that I would be looking at.
I have seen that like in the Firestone bags where they'll have that cone, and the cone is even shaped to provide some progression on compression travel. So the cone is a little bit of more like a cone instead of just a straight tube, and as the airbag pushes up or pushes down onto that cone, it actually reduces the amount of area, which increases the pressure. But then when it drops out, the cone actually will pull out a little bit to give that full range of travel. And is the ARB one similar to that?
Similar, but again, that can come into the packaging available, and trucks often use that technology and that structure, and they typically have more room, and they don't do a lot of articulation. So we have these added complexities around what we do. But probably one of the things that we have done differently is we have put a Jounce bumper on the inside of the bag.
That's clever.
That's some of the things that we've picked up through our investigations is the quality and the slimline design of the bracket and not taking up travel, but then it's also including a Jounce inside the bag, so that we can effectively we call purge it, or we can open the bag to atmosphere for when you are unloaded, because that pressure that you add, like you said in the Land Rover example, as you add pressure, you adding that rate and that stiffness, and so we've put a Jounce back inside the bag, so it would work like the bag's not there at all, and we vent the bag to atmosphere, and it can just breathe so it's not there at all. Because what we found is that there are many on the market that you have to add a 4 or 5 psi or a little bit more, so that the bag can act as the Jounce as it comes down to full compression. But then what we found on running that on the dyno, from a dynamic point of view, that 4 or 5 psi can be quite detrimental to the ride feel that you just described. So there's some of the small factors that we've dug right into.
That's great.
Understanding how we can optimize this as a system.
And what are some things that you have found help to improve reliability of airbags? That's one of the things that's always made them. I've always been so reticent to use airbags. Is that you just, like, even on this trip we've had several. I mean, I don't think that they were ARB bags, but we've had several on this trip on some of the other cars that were having trouble with the solenoid or whatever. What are some things that you found help to improve reliability?
Quality of those systems as well, and air's not a new thing for us, coming out of air locker and compressors, and that's where that has worked for us, is how that can be consolidated as a system. So as much as the bag can be vulnerable, the system, the air system as well, needs to be of significant quality to be reliable and dependable as well.
Yeah, and I think going into it, you just have to know that it's a complex system. An airbag system is a complex system. It should be a helper to your suspension, but I would not feel comfortable doing what we just did on a suspension system that relied on the airbag in order to work, because there is always going to be a chance that a stick goes up through there and punctures the bag, or there's some kind of a valve failure or a line failure or a compressor failure, any number of things. So airbags they can be very helpful. They can help you do even a little bit of load leveling in camp. Get that last couple degrees to get
a tent on the roof,
to get the
quite
tent
nice.
just right. Yeah, exactly. Very, very nice. All right, so now let's shift. This conversation is going great. Thank you, Stu.
Yeah.
So let's shift now to another component of another spring, in a sense, which is going to be our jounces. Now let's talk about the different kinds of jounces, like what you typically see in a factory application, and then let's talk about maybe some aftermarket considerations, and then maybe some higher performance considerations on the jounces.
Yeah. So even the jounce, I suppose, the jounce is a
Bump stop.
is a component. It's a bump stop to just ease you in for that last little bit of travel before everything gets fully compressed. So, you want a little bit of progression in there that is nice, so that you're not sort of compressing up and hitting a dead stop.
Sure.
And lots of vehicles have different rates of jounce, more progressive, longer contact.
Sure.
They can almost act as part of the spring, depending on how early they're brought in. I know some vehicles have this, we would call it a witch's hat, but a nice sort of pyramid within the coil. Yeah. And some have that, and then even an additional rubber jounce block on the frame where the axle does the ultimate strike at the end of travel. And then we have a lot more in the front end these days in coilovers that are coming from the factory that would have had a jounce, say between a lower control arm and a frame, a fairly structural area, bracket on the frame where that jounce would strike. A lot now we're seeing these polyurethane style, almost foamy jounts that are
on the shock shaft.
On the shock shaft, on the rod there. So.
Well, and you even showed me the other day, and this was cool, you even showed me a hydraulic jounce that's built into the damper, where the tolerance between the valve stack and the body of the shock at that very last, I would call it, 10 millimeters or so of travel,
15, 20
maybe
even,
15 or 20. It's the tolerance between those two are tuned so that the fluid, it takes an enormous amount of pressure to force that fluid between those two surfaces in that last 15 to 20 millimeters of travel. And that I thought was very clever too.
So it's like putting a puck in a little cup. Really. So the puck has an outside diameter that is just smaller than the inside diameter of the cup. And then we can tune that sort of annular area, or the gap between the puck and the cup, to control how quickly that fluid that's being trapped. As you push the puck in, that gap is then controlling the rate at which the fluid flows out.
And these bump stops or jounces or hydraulic jounces, all of them have a really important role to play. They are a safety component of the suspension because they're that last effort in the suspension to try to minimize the chance of a hard bottoming, reduce the rate at which you hard bottom to protect the shock shaft from bending, protect metal-to-metal contact. So a jounce is super important, and a lot of effort should be made in how you set it up. And there's a bunch of different options. So there's in the U.S. we have a manufacturer that I really like called Timbrin, and they make a series of jounces. Some of them they help like a secondary load engagement if you have a really heavy load. So it kind of works like an overload leaf or an overload spring. Those can be very helpful if you've got limited options. They also have a progressive natural rubber jounce that you can use. It's kind of their more overland or off-road specific one. So it engages a little sooner. So it really helps decelerate those loads because, if you go through, like in Baja, for example, if you go through these whoops, you can get incredible cyclic loads as you go to full extension and then slamming down to full compression. So it's doing whatever it can to try to save the car.
Catch that little bit earlier and make it a bit more progressive before you get to the ultimate bottom event. You're not loading up all of those components that are around the Jounce, you know.
But it sounds like you guys are doing that as well. You've got the Jounce on the shaft, and then you have that hydraulic Jounce or hydraulic
top out. We use
top
that feature in top out.
Oh, it's top out.
It's
Got
top
it.
out.
Got
Yeah.
it. Oh, that's helpful. So let's talk about. We just talked about compression Jounces. Let's talk about rebound Jounces.
Yeah. So I mean, back a while, you know, in recent generations of trucks, some had both a compression bump stop and also an extension Jounce stop as well. But more now that basically the coilover strut becomes the limit strap for the extension of the shock.
And it can be so harsh if it doesn't have some
Definitely.
feature to it.
And without going crazy stuff, you know, there's the benefits in mild to extreme lift, but as often as we go up in lift, we reduce that down travel, that extension of the shock. So as we're driving along the road, you can't have 1 inch down travel because you'd be continually topping out on that, and your wheels, the result is your wheels aren't staying in contact with the ground to be able to brake and steer and do all of those things.
Maintain traction.
Exactly. So it becomes unsafe. At the end of the day, it's unsafe. So we like to have that limit of available travel, rebound travel. So,
and what do you like to aim for? I mean, this was years ago, but
we have a roughie.
I remember hearing. I was reading some literature in one of the suspension like engineering guidebooks that I was reading, and they were on a typical passenger vehicle. You're trying to aim for about 70 millimeters minimum of extension travel. Have you found that number to be? Are you close to that?
So we have a rule of thumb that we like to start at 60.
Okay.
Because we are pushing the limits and getting into the grey areas of these you know, operation of these systems.
So you find that 60 is okay?
60 is our target to start.
Yeah.
To start, application specific,
Sure.
unsprung mass, tire and wheel, and all of that. So we could get a 60 mil, and that sort of sets how much lift we can give something as well.
Sure.
So we'd like to maintain that 60 millimeters of droop, and then if there's opportunity to lift, then we'll lift higher than that. But we like that for the reasons we spoke about, safety and steering and braking. You need to keep the tire in contact. But because we do, you know, sneak it up a little bit, and the events that we put it through, often you do get into that position where you get to the end of travel, and it can be a metal, you know, bang experience.
Right. You know, and for a lot of people, they think, how much lift can I get out of my independent front suspension vehicle?
Yeah.
And you really want to be mindful of that. I mean, there's other things that you can do to fit a bigger tire. You know, consider maybe a 20 mil body lift, or do some trimming, or maybe just accept the fact that you can't go with such a big tire. But you really, in an independent front suspension vehicle, you have an operating range primarily of the CV axles. So you can put on upper control arms, and we're going to talk about that in a little bit, but you can put on these fancy upper control arms that give you another 3/4 or so of an inch of travel. But all of that is going to start to push the limits of the operating range of the CV axles. So you really want to be careful doing that. So you have a static ride height of an independent front suspension vehicle, and that's going to maximize braking effectiveness, turning forces. The steeper the angle of those A-arms, the more poorly the vehicle will manage lateral forces, the more likely you're going to get body roll. There's a reason, if you look at the back of an F1 car, those A-arms are either perfectly flat or they're actually a little bit negative, so that way when they come in to a corner, heavy lateral loads, the roll center actually drops. It actually forces it down. It forces those A-arms down. So the opposite is happening when you have the A-arms at a really steep lifted angle. It's actually causing increased body roll and increased body lift, and you really don't want to have that. So you want to make sure that you get proper compression and extension travel. So anytime you're adding lift, you're robbing extension travel and you're gaining compression travel, but there is a limit.
Yeah, there's definitely a limit. And then often it is, you get all those detrimental geometry results that you discussed, but then you need to protect the CV angles and the CV joints, the ball joints of the steering system, and the ball joint in the upper control arm.
And I've seen all of those things fail. I've seen knuckles bend, especially on some of the recent generation Toyotas, when you end up with a lot of lift height. I've seen those long knuckles bend as well, and so that people are coming out with braces and all kinds of stuff. Yeah. But all that means is you're operating outside of its intended engineering specifications.
That effect again as you're modifying till you get a problem. And
that's right.
To solve that problem,
and think about it. If you've got an independent front suspension, and let's say you pull the front sway bar off, now you have lots and lots of droop on one side and lots of compression on the other side. Now you're in a tight main shaft angle. You put in a lot of steering input. You're in a really tight corner, and you flip on a front locker. That front CV is maybe operating at 30% of its available strength. Yeah. And that's when you pop an axle. So there's a reason why these things have operating ranges. So let's come back to like what Stu said. Let's aim for that minimum of 60 millimeters of droop travel. It's a really easy thing to measure. You don't even have to take the tire off the vehicle. Put it, sitting in your driveway, and put the jack up underneath there. Measure the distance to your fender well, to the top of the tire, and then lift it until the tire starts to, not be forced down on the ground. You can see the tire starting to lift, and then measure it again. And if you don't have 60 to 70 millimeters of droop travel, you've got too much lift.
Yeah. So and because of that, you can tune a car around it to try and not have these events where you're getting this top out knocking noise that's unpleasant. It's not good for the way. Apart from all of the geometry issues and things you're concerning and the safety, it's not a pleasant car to drive.
No.
So you've also now asking, the rebound tuning of the shock to work in such a shorter range.
A narrow range.
So you have to stick a whole more rebound control in there to then try and catch that front wheel in the event that it wants to come off the ground.
That's right.
So that it's not topping out. So that's why we've included this hydraulic end zone in MT64 for that top out event, to catch that last little bit of travel and control that last little bit of travel to take that metal to metal and loading through the system out of it.
And that's why for most overland vehicles, let's say you buy a new Grenadier, or you buy a new Wrangler, or you buy a Tacoma, you really are aiming for that 50 to 60 millimeters maximum of lift. You just don't need more than that. That's what all of these vehicles are running that we just did. One of the more difficult tracks in Australia, you're looking at that 1.5 to 2.5 inches of lift. And that's just going to give you that sweet spot where you've got enough rebound control, enough extension travel, good articulation, great ride quality, good limit handling characteristics.
Yeah. Because we're driving it, we're not trailering it.
That's right.
So we do need those limit handling characteristics. But we've just found that to be a pretty good recipe as well. We were sort of overlanding, and we've discussed it. We were sort of overlanding before it had a brand or a name. This is just the way we
Australians invented it.
But what we've found is that type of range works well for the customer and for the application, but it also works well for an industry. We're not loading up other components that we're not touching. We can address the little bits and pieces that we're modifying. Yeah. But like you've said, what are those loads that we're imparting on all of the other bits? Whether it's CVs or frame or control arms, the bits that we're not modifying through doing a lift. By keeping it within the realms of, reasonable, we're not loading up all those other components as well. And we're making it easy for fitters to fit, or for customers to fit themselves at home. It's not a complex system.
And you're more likely to be able to still get a warranty claim done on your car and all kinds of things. Once you start to push the limits, It may look cool going down the road, but you're really not gaining much, especially on the safety side of things.
Yeah.
All right, so before we get into dampers, which will kind of be the last segment, I want to talk a little bit about sway bars. So they could be called an anti-roll bar, they could be called an anti-sway bar, and what that's trying to do is limit the amount of body roll by using another form of a spring. There are cars that don't need them at all because they're tuned in a certain way. Early Land Rovers didn't have them at all because they wanted to maximize articulation. So anytime you're trying to control, everything's good? Anytime you're trying to control body roll with an anti-roll bar, you're typically going to be giving up some articulation unless it has a disconnect, which some Jeeps come from the factory with a disconnect, which is very clever. Some of the new Toyotas do as well. So let's talk. What's some of your approaches around anti-roll bars?
Yeah, so we do a little bit of anti-roll bar work. Typically for us, we work within the bounds of the OE anti-roll bar and really focus on it more on the heavy-duty overland builds. Like, I think,
this one's got to have a heavier one in the back.
It does. I don't think this one for a long time came from the factory without it.
Yeah, sure.
So it had a front one.
Yeah,
so
sure.
we did a supplementary kit, like bracket mounting kits. Often the axles would have the brackets and the mounting provision there. So we would have the sway. We work with a supplier. We did all the CAD for the sway bar. Have a manufacturer build that for us, but we located all the brackets and the droppers and everything from the frame. But we've done it definitely for the 70 series. We have a number of different anti-roll bar diameters. So basically it can be as simple in these cases of going up in bar diameter, gets you more rate to control the amount of roll. So 70 series, we had a number of different bar diameters that we could use depending on people's builds. We also had some really interesting cases where we were doing armoured vehicles, whether they were sort of military applications or private applications where you have a heavy vehicle because of all of that armouring that you've added. So we've done definitely anti-roll bars for armoured applications, because particularly within the glass house or all the extra, ballistic protection there, you get a lot of mass a lot heavier. Some that might have a turret in the roof, so changing that centre of gravity of the car, changes its roll characteristics. So we do.
Well, let's help the listener understand how anti-roll bars can affect the way that the vehicle oversteers and understeers. It's something that's very rarely understood. What's the reason why you usually find a front anti-roll bar with a really heavy rate? Why do you typically find that in the front of a factory vehicle?
Normally to be able to get around corners and not transfer load laterally.
That's certainly one of the things, and this is what's interesting. All of the safety features of a vehicle are built for a front-end impact, because that's the thing that's the most dangerous, is a off-center impact or a head-on collision. So as a result, manufacturers tune sway bars to cause understeer, so that way you go straight into the ditch, where all the airbags can work, the crumple zones can work. You go straight into the tree, so the same thing happens. So Toyota in particular, but most manufacturers heavily favor understeer. So the heavier the sway bar is on the front, the more likely you're going to have understeer. If you were to take the sway bar off the front and put a heavy one in the rear, you would be more likely to have oversteer. So you can, as a driver, depending on your preferences and your experience and how you want the vehicle to handle. I like a vehicle that handles very neutral around a corner. So that means it's going to hold the line and maybe even favor a little bit of oversteer, because I feel comfortable with that. But what I don't want is, under heavy braking or heavy turning loads, the vehicle to just push through the corner and plow through, which is very difficult to resolve as a driver. So just be mindful, if you take a 70 series that had no rear sway bar at all, and you put on a super heavy one in the back, that vehicle is going to be now favoring either being more neutral or even some oversteer.
Yeah.
So we have to just be thinking about all of those impacts of that, and make sure that we come in eyes wide open of like, why do we want to do that? And there are certainly times that we do want a heavier rear anti-sway bar.
It's a consideration as part of the system, really, isn't it? You know, when you have your leaf springs, you have your mass that's on it, and then you have your sway bar as well to control that characteristic.
That's right. All right, so a lot of times people will put in disconnects on their anti-sway bars. That way you can gain back a lot of articulation. I would have liked to have had that on this 70 series. After that trail, I was doing some big wheel lifts because it has a heavy front anti-roll bar. So that's kind of the last of the components that I wanted to talk about as far as that goes. Let's get right into the dampers now. So let's describe to the listener, what a shock absorber, what a damper, how it's made, what is its job.
So a shock absorber is basically, as we said earlier, its job is to control the motion of that mass on the spring. So as the shock absorber goes up and down, there's an outer body, an outer tube, and then a piston rod in the middle, and they're joined by a piston on the end of that rod that pushes through fluid that's within the body of the outside of the shock absorber. So as you push the rod in, fluid has to flow typically through the piston, and the restriction in that piston is what creates your damping effort. So if it flows through the piston really easily, you'll have a soft shock. If you have more restriction there and it's hard for the fluid to flow, then you'll have a firmer shock. Typically in most dampers, that's a stack of shims or thin plates, thin discs on either side of the piston that flex open as the oil pushes against them. So if you have thin discs, they don't provide much resistance to that oil flow. If you have thicker or more discs, then you provide more resistance, and that's how you tune the shock absorber.
And then how does it manage rebound? This is kind of clever how shocks do that.
Yeah, so then on Rebound, it has a similar shim stack on the other side of the piston. So on the piston itself, the way the piston's created, oil flows in around the shims on one side, but then has to push shims open on the other. And then on the Rebound side, same thing, it flows in freely on one side, then flexes the shims, controlling the rebound motion of the shock.
And that's how you can tune compression and rebound differently based upon how the shock is set up. So now the more compression and rebound control that we put into the shock, what's the byproduct of that, all that control?
So, and that's probably the concept of the shock absorber, really, isn't it? Is that it converts that motion, that up and down motion, into heat. Yes, so the restriction, the friction that you're putting in there, as it's restricted flowing through that piston, it's generating heat.
That's right.
So you're converting motion kinetic energy into heat energy, and that heats up the oil, and then that gets out to the atmosphere through the body material of the shock absorber.
Yeah, heat management is the bane of most damper manufacturers, because they don't want, what'll happen once that shock gets hot, the viscosity of the oil changes, begins to thin out. There can be mechanical damage done to the inside of the shock, which can include damage to the seals. But most of the time what happens is the fluid gets very thin, and then it is what's going to be called shock fade, but that's actually just because the fluid viscosity isn't as thick as it used to be, and it's flowing more freely, so you're getting less control.
Yeah. And then that's before we go into nitrogen and pressures and and cavitation and all of that. But that's it. And definitely heat is your enemy, particularly around seals. Once seals give up and oil goes, then the whole game's pretty much over. So heat is the enemy.
And nitrogen, let's maybe talk through nitrogen. Nitrogen, as I understand it, has two important roles to play. What are those roles that nitrogen plays?
So for me, the nitrogen keeps the pressure up against the fluid, up against the faces of the piston, up against the shims to make sure that that's flowing through there.
So it reduces cavitation, right?
Yes.
Yeah, that's right.
Because air bubbles or cavitation within the shock will flow through that valving a lot easier than oil will. So
and it can cause foaming of the oil and all kinds of
other downsides. And once that starts, then you've lost that control, you've lost that performance.
Let's talk about some of the mechanical characteristics of the damper. So let's talk through what should people be looking for in the shaft, like shaft diameter, shaft materials, things that, how do you protect the shaft from rock and ding?
So again, depending on your application, the shaft basically connects that shock absorber together. So if it's too thin, it's going to bend. Yep. You need the right materials to have it not bend as well and be durable enough. And then you need a finish on there that is going to be durable against any sort of damage that may compromise the ability of the seal to seal against that shaft as well. So that's
and that's normally where shocks fail, is they fail at the seal, and then you get a weeping shock or a leaking shock, and then it's just a matter of time before the fluid volume goes down enough, or it starts to compromise the effectiveness of the shock.
Yeah, and then depending on the more aggressive nature of your use, you can go up in the quality of those materials for their structural integrity as well.
Yeah, and we want there's a couple balances. If the shock shaft diameter is too big, now it's taking up fluid volume. You're reducing and you're reducing the adjustability that you can have on compression and rebound with some of your valving. But you want the shaft to be big enough that it doesn't bend. You don't want the shaft to bend under a heavy impact. And a lot of times that can happen. Shocks can bend and get damaged.
Yeah.
And then how do you like to, or what are some of the more effective ways you've seen of protecting the shaft from rock dings and all that other stuff?
Yeah. So typically and historically they were steel, probably steel dampers, steel stone guards. Then we sort of got into the polyurethane style boots, concertina boots,
which are just less expensive and they're lighter.
Less expensive, they're lighter, they keep the dust out. Yep. And then, depending on whether that's a twin tube damper or a monotube damper, some monotubes can be susceptible to stone damage, which can compromise the ability of the piston on the inside of that wall to work. So often a monotube will be mounted so that the body is up the top and out of harm's way, but then that can make the shaft more susceptible to damage. Right. So then putting a guard on that shaft, particularly in the terrain that we've been through, where there's stone roost from front tires and on these types of trips with all-wheel drive vehicles now, or just being in constant four-wheel drive or in high four, with mud or aggressive, all-terrain tires, picking up big rocks and throwing them at those rear shock shafts. Sure. You need to have some guarding on there, and the way we've found to be really successful is a injection molded.
Yeah, those clamp-on plastic
boot.
I like them.
They can be a consumable.
They swap them out.
You don't want them to be brittle, and you don't want them to break in service. Yep. But if you do a really aggressive trip and they get some damage, they're very functional. But if they're purely cosmetic damage, it's a consumable part that you can replace.
And a special thanks to Treader for their support of this week's podcast. One of the age-old problems of vehicle-dependent adventure travel is something that you probably don't think of very often, and that's insurance. If you've put a lot of money into your truck, chances are that those modifications aren't covered by your current carrier. But now there's Treader. They fill in the gap between what your car insurance company thinks your truck is worth and what it is actually worth to you. You don't have to switch your carrier, and you can use regular insurers that provide the stock stuff while Treader insures the cool gear. Head to Treader.com and check out their easy 5-minute quote process to see if Treader is the solution for you. Again, that's treader.com, TREDDER.com. Thank you again for the support, Treader.
Well, and a lot of people don't know the difference between a monotube and a dual tube damper. The monotubes have advantages on heat dissipation. They're also a little bit smaller on packaging. But what are some of the benefits of a dual tube?
So yeah, a twin tube, our nitrocharge is a twin tube, and historically in this overland type market, twin tubes have been very popular because, as their name implies, there's two tubes. Yep. The piston runs inside the pressure tube part where all of the damping happens, and then it has a base valve that the oil comes out as the shaft comes in and displaces that fluid. It pushes out a base valve and then round into a space between the inner and the outer tube. So that we call that the reserve tube. So as the rod pushes in, it pushes fluid through out of the base valve and it takes up the gap in between those two tubes. So a little bit of damage on that outer tube, as long as it doesn't pierce, if it's deformed a little bit, can be okay to the function because it's protecting that inner tube that can still operate.
And you have some benefits of increased fluid volume.
Exactly. You have increased fluid volume, and a big benefit of a twin tube is the travel. So it's quite efficient in producing extended lengths for its compressed length.
Okay.
So when you put that within the architecture of the vehicle, you don't have to compromise the amount of shock absorber compressed length for what achievable
That's
extended.
Cool. I didn't know that.
Which is so if we use that now and we sort of compare that to a monotube. So a monotube is one cylinder being the monotube. So within that you have the shaft holding the piston, and then below that you would have a floating piston that would separate the oil from the gas in a monotube.
Sure.
So in that monotube, so that's the packaging, yeah. So the floating piston or the separating piston and the gas come out of that monotube, come out of the tube, and now occupy that space between the two tubes. So twin tubes typically won't have a floating piston to separate that oil from the gas. The oil naturally falls to the bottom of the tube.
Sure.
And the gas sits above it, and then it goes through the base valve. So that's why a twin tube has to be mounted up that way to keep the gas in the outer tube up near the top and the oil down near the bottom. But the benefit of that is we don't have a floating piston and a gas chamber and a gas volume that is in series of the whole operation of the damper.
That's cool. So if you're looking for a little more travel
Yes.
out of your damper, you can gain some with the twin tube.
Yeah.
And if you're looking for a little bit more efficient cooling, sometimes you can get that with the monotube. And a lot of people like monotube shocks.
Yeah.
They like the way they ride and they like the way that they handle a lot of times. So let's talk about some other components of the shock. Let's talk through the benefits of synthetic bushings or the benefits of natural rubber bushings in dampers.
Yeah, and we've probably used both for different applications. Our direction at the moment is along natural rubber, and we like it for its suppleness.
Yeah.
It's
very quiet, no rattles.
Very, very quiet,
no
no rattles, no squeaks. It's quite stable over a temperature range as well. You know, definitely heat is the enemy of the damper, but so is cold.
Sure.
You know, and we learned that through our initial BP51 testing. You know, we were testing in national parks and state forest when it was well into the mid 40 degree temperatures. There were bushfires going on around us because that was the thing. You know, it was the hot. You know, that was going to be detrimental to the shock and detrimental to the seal pack and the way it all operates. But cold can be detrimental on seals and on bushings as well. But rubber has that good stability over that temperature range.
And
as well.
natural rubber itself has its own natural lubricant to it, so it does keep for most squeaks from happening.
Yeah.
So you don't tend to get that squeaky shock.
Yeah, and that natural rubber bushing can be one of the most challenging parts of the whole suspension system for us these days. You know, coming up with that bushing, particularly on front factory replacement coilovers. So not fancy coilovers, but just a strut that's as a factory replacement. That has to provide all of those features of the isolation, of the loading, and of the compliance to be able to take those loads in both sort of that radial direction and in a torsion as the arms twist. So they have to be very capable, and there's a fair bit of science that goes into developing those bonded bushings that work in compression and in extension.
And then, of course, the worst kind is going to be like a full race suspension where it's a Heim joint or something on one end that doesn't have any damping characteristics, and they're designed for racing. So if you got a little bit of a rattle on a race truck, it's not a problem. You're looking for durability, for ultimate strength, and then it can be rebuilt after every race. We don't want to be rebuilding our shocks after every trip. So I think we want to be looking for a quiet, comfortable, either synthetic or rubber bushing in the dampers on both ends if you can. Sometimes application specific, there just isn't a bushing on one end, but it just depends. If you've got a little bit of room for a good bushing, it can help really reduce that noise, vibration, and harshness from the damper itself. All right, so let's shift on to another component you see on a lot of shocks, which is going to be a remote reservoir. Tell us what a remote reservoir does.
Yep.
What are some things to look for in a remote reservoir?
So the remote reservoir, like we spoke between a twin tube and a monotube,
Yep.
one of the first obvious differences is we can get that travel back that we may have compromised in going from a twin to a mono by taking that floating piston and that gas out of the shock absorber body, out of the travel zone, and put it into the canister or the remote reservoir. So that allows us then to get that travel back, but also allows
So you can have a monotube with a remote reservoir and gain some of that packaging back.
travel,
See,
and put
also
and
didn't know that.
yeah. So and that space that was just in a pure monotube taken up by the floating piston and the gas, that's now got oil in it, and also through the hose, if that's the way that the remote is connected. And in the top half or in the top section, maybe not half, but in the top portion of the canister, there's oil as well. So we have that oil volume now to be able to spread that heat that the piston is generating through more oil volume.
And a lot of times those remote reservoirs will have cooling fins, or they'll be made from aluminum to help dissipate heat. A lot of times they're in an ideal packaging situation for airflow. I mean, airflow is really important when it comes to keeping shocks cool.
Yeah, it is. And we've done testing. It's probably 2008, 2010. We went out into a different part of the desert towards the centre of Australia, Broken Hill. I'm sure you're familiar with it. And we're running up and down sections of corrugated road there. And what we were finding is, like today, where we've sort of got the wind blowing across the road, we were running these corrugations at the worst possible temperatures we could. So we had everything thermocoupled, and we had potentiometers on shocks to see what was going, and we'd drive it at a pace that would generate temperature in the shock. To try and find that worst case, to really give it a hard time, test the oil, test the seals, test the components. And what we found is we'd run for perhaps a couple of kilometers up the road in one direction, turn around and run back, and we'd get different shock temps depending on the direction we were going. So not only into the wind, but as the wind was blowing across the car, the left versus the right-hand side of the car would have different shock temps. So it definitely makes a big influence on cooling of the damper.
Yeah, and again, heat is one of the biggest considerations, particularly when you're doing heavy loads, lots of corrugations for hundreds, if not thousands of kilometers. You're really trying to manage heat. So the remote reservoir is something that we see oftentimes on shocks. It helps increase that fluid volume, increases the service life because the fluid can last longer, run cooler. There's a lot of advantages that come for it. Also can give some tuning even in the reservoir itself. But then you always have increased cost, and then you also have like how do you mount the reservoir? So that becomes a factor, making sure that the reservoir can't be impacted by the front tire during a steering sweep, compression of the suspension. So there's a lot that has to go into making sure that gets mounted properly, and heaven forbid doesn't come loose and fall down into where the wheel is. That would be quite catastrophic. So we always want to be mindful of high quality components with good mounting hardware.
You want reliability.
Yeah, you want to manage the liability. All right, so then there's another piece of technology that we're seeing more and more of now, which is going to be, people have seen external bypass shocks on race trucks for Baja 1000 or for the Dakar and things like that. And that's where there's these huge external tubes that allow for fluid to move from one region of the shock to another to change the way that the shock manages impact throughout the stroke. But now what we're seeing, and it's very clever, is internal bypass. So it's done within the shock body itself, within the machining of the shock body. And the only couple that I'm familiar with is BP51 and then the Multimatics are the ones that I'm familiar with.
Yeah, and that was a big challenge. BP51 was a big challenge that we were set some time ago now. I think we finally got that product to market in 2014. It took 3-4 years of development work, and the concept of that technology is a great one for our customers and the way they use vehicles. And basically those tubes that almost look like handles, you know, on the race shocks, take fluid around the piston rather than having to funnel it all through from one side of the piston to the other. They create this alternate path through the tube, which they call the bypass, so that it bypasses the piston to go from one side of the piston to the other side. And then you can put a valve on that tube or that bypass path to create some different valving or different performance effects as well. And the positions that you basically put the holes or position that tube also affect the performance. So you not only now have fluid flowing through the piston, you have it flowing through these bypass tubes. And traditionally with a monotube, a twin tube damper, the faster you push it, the more force it provides, and we call that velocity sensitive. So the higher the speed, the faster you push the shock, the more force you get. So these bypass shocks are still operating in that same manner, that the faster you push them, the more force they provide, but we also get what we call is a position sensitive damping or bypass damping, where the fluid not only flows through the piston but around this bypass tube. And the result or the benefit of that to the customer is that you can have a plush middle section where you're pushing fluid through the piston, but also from one side of the piston to the other through these bypass tubes. And the more tubes, I suppose, you have at ride height, the more opportunity there is for oil to flow around, and the softer you get, the plusher you get it.
Yeah. And then once you come into the middle of the stroke or even closer to the end of the stroke, then that's where your valving in your piston becomes more.
It does all the work.
It does all the work, and that can be very firm.
Past that junction of the tube coming back into the main body of the shock, there's no way now. There's no other path, no other opportunity for the fluid to bypass the piston. It's all going to flow through the piston, and ultimately the damping ramps up in that end zone once you've run out of bypass tubes to be using. So the benefit again there to that customer is that you can be driving along here quite plush, you know, at ride height, but then for us, you know, that's that unexpected event as an Overlander and in the traveler we've been doing. Yeah, you know, you come around the corner, you're a bit hot, you're carrying a bit much, you know, pace, and you jump on the anchors, and then you brace for impact. Yeah. And you get into those end zones of travel, and the damping ramps up when you need it. And I suppose the alternate is, you could have a generic twin monotube, and you could have that same effect by just putting more damping in the shock.
But then you have to deal with it in every other part of the
Every
travel.
other bit of the travel, it's going to be way too firm. On the flip side to that, you make it comfortable, you soften it right off, but then you hit that G out event and you bottom out. And I think, it is a race technology. It's come out of, the race scene and the way those guys, throw those trucks and buggies around. But
There's a lot to learn from that too.
It is really applicable to I think, the overland travel, because overlanding, you're typically carrying a lot of weight. You're driving for long distances.
In unfamiliar
terrain, so there's potential of G out, and you can be remote. So if you have that G out event, there are safety question marks there of what that can do to people and to vehicles and to durability of components. So we're providing this technology now that if you've got all this weight on board, you've found yourself in that event, and you haven't had the impact, you're now able to carry on your journey,
and with a lot more confidence.
Exactly, and for the remainder of your journey, when you're not having that event, you have the level of comfort that the bypass or the position sensitive damping gives you.
Right.
So you're not being physically fatigued. You're not being fatigued. Your passengers aren't being fatigued. You're arriving to the camp refreshed and alert, so that you can physically drive the car. You're attentive.
Yep.
Whereas, you valve that shock up to hit the G out, and you're rattling your way down the track, you're going to be just drained and fatigued.
No question.
Which is not good for safety. It's not good for you're on holidays. You don't want to be living like that.
Yep. Well, this has been an amazing conversation. I mean, for me, I think this is my takeaway, kind of the wrap up that I would give to the listener is they call it a suspension system for a reason. It's an entire system that works together. That can include upper and lower control arms. Some people do change out their upper control arms, but be very mindful of that. Again, you don't want to go with that Heim joint style system. You want to go with the proper ball joint that has a lot of durability and a long service life. But that can provide some correction to camber that's necessary depending on the lift height. It can also give a little bit better range of travel, make sure that the wheel travels properly. And then we're always going to be mindful of the types of bushings that we use, the types of control arms that we use. We always want this stuff to be serviceable. Anything that makes a permanent modification to the vehicle, think long and hard before you do that. Because if that component breaks in the middle of Baja, California, it's going to be maybe easier to find a stock upper control arm or a stock lower control arm or a stock 5-link component from a Jeep than it is to find some super unique component. So you want to make sure that you're using a system that is as close to stock as possible. Keep that ride height changed to a minimum, just a couple inches, and just a couple inches maybe on the tires to match that. Go with a high quality shock absorber to help control the heat and give you some more confidence in your driving. Tune your spring rate to your load so that the vehicle sits properly. And then at the end of the day, always be focusing on safety. Drive within your limits, drive within your experience, and make sure that you're not introducing failure points into your suspension that could end your trip. So how about for you, Stu? What would kind of be your wrap up on this segment?
Yeah, a lot of it is around function and around reliability. You don't, exactly like you said, you don't want to be in the middle of the bush here or anywhere in the world.
That's right.
Where they have bush and you're away, you're remote, you're by yourselves. You want reliability. You want to be able to depend on the parts you've got. If that's what you're doing, if you're just doing it in town and it's a fashion project, then it's something different altogether. That's but right. I think what we're focusing on is product that functions correctly and that we can rely on. Yeah, to have an enjoyable vacation and an enjoyable journey around the world.
Awesome. Stu, it has been such a joy to have this conversation with you, and the timing couldn't be more perfect. We're just coming into Archer River, where I know they've got good coffee. So, and I feel like I need a coffee, even though
Pretty crazy
the
burger
conversation
too.
was riveting. Let's make sure
It's coffee time.
We stop and get a good coffee. But we thank you all for listening, and we'll talk to you next time.